All right, recording's pretty rolling. We're closer to the end of class. Going over the solutions with you guys. Just ask guys how you thought you did, and got a couple teams that think they got this. So let's find out. All right. So like I said, if you follow the leading questions on the right side of the page, they eventually lead to the answer. Actually, two different ways. I'll show you guys at the end. So first question: what distance did the light travel from the wheel to the mirror and back? Because this is a two-way trip, isn't it? It's from the source, say like from the wheel to the mirror and also back, right, to the observer. Right? So I told you the separation distance in kilometers. Now I'll do my numbers. Have different numbers than I do. Mine says 4.8 kilometers is the separation distance. So if the separation distance was 4.8 kilometers, right, what is the total travel distance? Is that two times the separation distance? Which would it be? Four is eight. So what 9.6 kilometers, I think. Okay. But one more thing, it's safe to have all your values in base SI units. In fact, that's what I prompted right here. It said how many meters. Okay. So guys, how many meters is this equivalent to? 9,600 meters. There you go. All right. So I would put 9,600 meters there. Okay. Right. Again, everybody's numbers are different, but the orders of magnitude should be about the same. Okay. Second question. Well, how much time would it take for the light to travel back and forth? Right. Now, of course, we're solving this backwards from how he was solving it, right? Because you guys know the answer to his question. You guys know what the speed of light is. Okay. Hey, isn't distance equal to speed times time? Wouldn't that be true? Right. And since you know these two things, or maybe we should call this D to match what I've been doing up here, right? Since you guys know these two, can you just solve for time? Right? Wouldn't time have to be how far did it go at what rate? Right? Distance divided by speed. Right? So we're looking at well, here's my numbers anyway. 9,600 meters. Right? You guys have a different distance. And speed of light I gave you. I normally say 3 times 10 to the 8 meters per second. I went ahead and listed out the digits here, like 2,997,924,5,8 meters per second. That's way too precise, but I don't know, just for fun, why not? Like 300 million meters per second. So this should be a tiny, tiny time interval, which should make sense because it should be only a little time to go a few kilometers per light, right? That's hardly that. Right? I mean, if you make a cell phone call to someone like across the country, it feels like an instantaneous call, right? Right? It shouldn't be a lot of delay. So that many meters divided by that many meters per second gives you how many seconds? And I'm getting a tiny number of seconds, 0.0000 something. Okay, that's about right. Okay. Are you guys also getting, not the same digits necessarily, but maybe the same order of magnitude? Should start off 0.0000 something. All right, all good so far? Next question. How far should the wheel turn during this whole process? And let me zoom in here. Remember, I was saying that for the light to bounce back and forth, the wheel is turning, and it should have turned so far so that this tooth covers an adjacent gap, right? So if you know the number of teeth on the wheel, that should help you figure that out. Like, for example, if there were 8 teeth on the wheel, or sorry, yeah, then it should turn like a 16th of the way, right? Because they're like 16 things, right? 8 teeth and 8 gaps, right? Okay. Right. So my wheel has 40 teeth. I'm not looking at the picture. I'm looking at this box down here. My wheel has 40 teeth, right? So isn't that like 40 teeth, but also 40 gaps? That's like 80 different things, right? I want to think about it. So how far does it turn? Theta equals, right? So we're solving for theta. Again, it's just this little sliver here. Might be a few degrees, but I want it in radians, right? Well, here's the way I'm thinking of it. I know that 2 pi radians would be 1 complete revolution, right? 2 pi radians would be 1 complete revolution. However many teeth you have, don't you have to divide by 2 times the number of teeth, right? Right. Again, if you had 8 teeth, it should turn a 16th of the way. 2 times 8 is 16. You're dividing by 16. Right. So I'm going to take 2 pi radians for 1 complete revolution. That's where that comes from. Right? And divide by 2 times 40 teeth. Right? So my wheel has to turn an 80th of a complete revolution. Right? The 2's cancel if you like. You can just do pi divided by the number of teeth. Right? And you're going to get a tiny number of radians. Of course, it's a tiny number of radians because, in terms of degrees, which maybe is more intuitive, that's what we learned. Like in elementary school. It's kind of what gets baked into our brains. It's only a few degrees. Hey, I wonder how many degrees this is. 0.07854. You can times pi over, or sorry, times 180 over pi to turn degrees. Okay. So my wheel has to turn about 4.5 degrees. Everybody's wheel is different because everybody has a different number of t. Okay. But I'm going to put the number of radians here. 0.0 something. Are you guys getting 0.0 something for radians? Something pretty close to that. Okay. All right. I'm going to skip this hint and work on down the page. And then at the end, I'll show you guys 2 different ways to get to the final solution. So next question then is, what is the radius of the wheel? Radius of the wheel. I gave you the diameter of the wheel in centimeters. It's how do you go from diameter to radius?
Divided by 2.
Yeah, divided by 2. Right? Also, I gave you centimeters. Guys, how many centimeters are in 1 meter? 100. How many cents in a dollar? 100. Right? So if my diameter is 84 centimeters, how many meters is that? 0.84. Right? I want everything to be in base SI units. That'd be meters divided by 2. It's be 0.42 meter radius. Right? 0.42 meter radius. Okay. Everybody's numbers are different, but should be kind of in that ballpark. All right. Any questions so far? Questions so far? Good. All right. Next question. How far would a tooth have to move during this process in meters? Right. And it's probably a tiny number of meters. Might be like a couple centimeters or something like that. So how far? Okay. Well, that's where we're going to break out this hint right here. How far something moves is how far the turntable turns times the radial distance from the edge. Okay. So if I'm watching these Roosevelts and say, how far does a Roosevelt move? Well, one near the center doesn't move that far, but near the edge, because it has this huge radial distance out here, right? So it's right here. Right? It's going to move a pretty good distance, right? Pretty good distance moving. Right. So that's what we're thinking like that. So I'm going to go, how far something moves is equal to how far it's turned, the turntable turn, wheel turn, times the radial distance from the center. So, hey, I know how many radians. It's 0.078 something radians. That's that number right there. And I know my radius in meters. How many meters feeds in right there? Okay. So let's put that together. Okay, and this will tell me 3299. Right. Well, it's really radians per meter. You can think of it like that. So it's still meters. It's still a unit of meters. Okay. So here, 0.0329 meters. Okay. So meters. Okay. For context, my number is a little over 3 centimeters. You guys know what 3 centimeters is. There's about 3 centimeters right there. Okay. So this big old wheel that I have only turned about this far. Well, a tooth would have moved that far during this whole process. Okay, you guys got that? Okay. What is the linear speed of a tooth? Linear speed. Hey, that's where are we going here? That's how far and how much time, right? Here's how far it moved, x. Here's how much time, t. Hey, I can just divide those two. It went this many meters all during this many seconds. That's a speed in meters per second. Right? 0.032. And it should be a big number. Now I've got a number in the thousands. Okay? Which makes sense. This wheel has to spin crazy fast. Okay? Now it didn't move very far during this process because the speed of light is so crazy fast itself. Okay? But yeah, I'm getting like over 1,000 meters per second would be the speed of a tooth. All right, all good so far? It's working out for you guys. You guys get numbers that are not exactly my numbers exactly, but yeah, same order of magnitude. now let's go in for the finish. Figure out how fast this wheel is spinning. So angular velocity in radians per second. I want to show you guys two different ways to get to the answer. Two different ways. Right? One way is with this hint right here. You guys see V equals omega r? Can I rearrange that and get omega, that's angular velocity radians per second, how fast it's rotating, is equal, which is what we're trying to find, is equal to V divided by r, the linear speed divided by the radial size. Okay? So that's this many meters per second is my linear speed, divided by the radial size in meters, which is this box right here. And the meters cancels and it gives you radians per second, which is exactly what you're looking for. Okay. Now, hang tight because there's still one more thing I want to show you. Okay. There's still one more thing. Okay. Right. So is everybody okay so far? You guys got any questions? Okay. It's all working out. Okay. The last thing I want to show you, I think some of you guys figured this out too, is that these last three boxes on the right side, you didn't actually have to figure out anything about how fast the tooth is moving. There's actually a faster way to the answer. You guys see this hint halfway down the page says, actually one method is you could just use something with these top boxes. Right, let's do that method. Do you guys see this many radians and this many seconds? Hey, could you guys have just done this? Angular velocity is some number of radians divided by some number of seconds, right? So it's two different approaches. You could do V divided by R, but you could also do theta divided by T. Let's see if that gives us the same answer. So we went 0.07854 radians, this many radians. And we did this all in a tiny, tiny amount of time in seconds. Right? Right? And that's given me this many radians per second. And oh, look at that. Right. I mean, there's a little bit of rounding here and there, right? But besides that, it's a match. I see it's a match. Boom. Right. Actually, I like that method a little bit better myself, so I'm just going to write that number. Okay. Right. Right. So there you go. There's two ways to finish that off. Bing. Right. All good? Okay. When you guys finish this page, remember the other side of this paper we've been working on the last couple of days. Okay? So turn this into the gray tray, and I will give you guys points for it. Turn it into the gray tray. Gray tray. That's a wrap on today.